Hey there, I'm Yakov. This week, let's talk about testing. I know, nobody likes writing tests. But you know what else nobody likes? Finding bugs. Also, releasing hot fixes in a rush, when your app is crashing and your hands are shaking. So, whether you like it or not, testing is an integral part of software development. And it is here to stay. But writing tests doesn't have to be a form of torture. Furthermore, after having written, reviewed, debugged, and fixed many hundreds of tests over the years, I noticed one thing. When people view tests as something pointless, a simple waste of time, those tests rarely end up being good. That applies to me too, of course. That applies to me first and foremost. When I don't feel like writing tests, I start to lose focus, and I can easily overlook an important use case. But again, writing tests doesn't have to be something boring and unpleasant. You can make it feel like a game, where you are trying to outsmart yourself and come up with a scenario which breaks your own code. And then you go back to this code and make sure it can no longer be broken. But first things first, there's many people who are absolutely new to automated testing. And I know quite a few who've been in the industry for years, but haven't written a single test. If you can relate to that, that's okay, there's nothing unfixable. Let's just start with the basics. Right after I ask you to subscribe to the Silverbird. Well, I just did. I guess now we can start. When you are working on an exciting new feature, it's understandable that you want to ship it to the users as quickly as possible. In a situation like this, you might be tempted to skip all the tasks that don't feel essential. Adding tests, writing documentation, checking special cases, and so on. I totally understand this temptation. Heck, I've been there many times in my career. That's because I really enjoy seeing the growing number of users on the latest version, with all the great features the team and I have been working on. That feels really energizing to me. But at the same time, there's more than one reason why you shouldn't rush to release like that. Moreover, giving in to this temptation can cost you a lot, and you'll pay in the most valuable currency, user trust. Let's have a look at a simple case first. Pretend you're working on a pet project, a small app that has just a couple screens and maybe fetches some data from the network. This project has only a handful of users, and they all realize that it's a pet project, so they don't expect 100% of uptime. When you add or change something in an app like this, it's fairly easy to just run it in the simulator and manually check every screen. If something's broken, you will notice it right away, perhaps. But things start to add up quickly as your project grows. On the one hand, you probably have more than a couple screens at this point, so checking each of them now takes a lot of time. On the other hand, you have more than a couple users. In other words, you've got harder tasks and higher stakes. You can't go on like this for too long. Eventually, something will break, and then you'll have to rush even harder just to fix everything. The alternative to these manual checks is automated testing. Well-written tests run quickly, require very little maintenance, and when something breaks, they point to the exact place and reason. But automated tests impose certain overhead. First, you need to spend some time setting up the infrastructure. Then you have to write tests for the code that already exists in your project. And sometimes adding tests calls for significant changes in the code itself. Finally, each test from now on will likely require adding or updating tests, which again takes time. But perhaps more important than time is your focus. It's not very easy to keep track of many things at once. Features, bugs, changes in the SDK, and now tests. It's exhausting and makes mistakes more likely. Sadly, I don't know a secret recipe to completely prevent this, especially if you work in a small team. But in the end, is it even worth it? Well, here I am quite confident. Yes, in most cases, the time and effort you invest into tests will pay you back. Unless you're working on a very simple project and have no plans to scale it, automated tests will benefit you in the long run. But from what I see, it can be tricky to identify the exact point where tests stop being a useless burden and become a necessity. I've witnessed projects which implemented tests too early, and also projects which did it too late. Some of those projects were my own. I would say if your app has more than a couple screens, or you plan it to have more than a couple screens, then you can't avoid writing tests. And since most apps are not as primitive, you are practically guaranteed to work with them at some point. Now that this thing is clear, let's dive into the details of what we test and how we do it. A typical app consists of many different components. Individual views, entire screens, business logic in the form of controllers, services, managers, and so on. Plus, there's also the backend, which from the app's perspective may seem like a black box. You know what comes in and what goes out, but you don't know and can't really control how it works. While testing the server-side code isn't something app developers are expected to do, many of their own components rely on a certain behavior of the backend. So to properly test the code of your app, you sometimes need to simulate the backend behavior. The good news is that you can implement automated tests for nearly every part of the app. The not so good news is there isn't a single tool or technique which can be used universally in every situation. Different components solve different problems, and testing them often requires different approaches. It's one thing when you have a self-contained service, which for instance formats dates. For such a component, you usually have an explicit set of requirements. For input A, the service must return output B, something like that. It becomes a bit more challenging when different components are linked together. For example, when before formatting a date, you have to get a response with the date from the backend. And testing the user interface is a whole different story. There are tools for each of these cases, and even more. But to someone not familiar with testing, they may seem like totally unrelated things. So getting started may feel overwhelming. While there is something to it, you don't have to use everything at once. Start small and then add new types of tests as needed. Maybe you don't even need all of them in your project. Here we have the question of what is rational to test and what isn't. It's not all or nothing. Many apps in fact have some parts intentionally left untested. For example, it's not uncommon to rigorously cover the business logic with tests, but check the user interface manually. And in the next section, you'll see why. The components in your app differ from each other, and the tests you write for them are different too. But they're not different in some abstract way. The differences come down to a few key aspects, and the main one of them is the scope. In other words, it's how much of your code base is checked by a single test. The two other aspects follow from the first one. How easy it is to write, use, and maintain tests, and how many of them you need for sufficient coverage. For instance, unit tests focus on very small parts, individual functions, or even some portions of them. That means you need a lot of unit tests to cover every function in your project. It's not uncommon for a medium-sized app to have thousands of unit tests. But on the brighter side, such tests are really easy to write. And if something breaks in your app, the fail test will show exactly where you should look for the bug. The scope of component tests is limited to a single component, the date formatter for example. They make sure its different parts work properly, but while unit tests attempt to isolate your methods from each other as much as possible, component tests check how well they work together. But components in your app don't exist in isolation. You use integration tests to check how well they interact with each other. For instance, the user manager component may behave differently depending on the data it gets from the database service. But if a test fails, how do you know which component is responsible? Maybe the database service broke the contract and provided an incorrect value. Or maybe the user manager failed to handle a correct value from the service. Or maybe they both have some issues. Because of that, when a test breaks and you have to investigate, you've got more than one suspect. Maybe it's this method which caused the failure, or maybe it's that one. To fix this ambiguity, you test components one by one. And not just that, but you also replace all dependencies with helper objects you control. They're called test doubles. In the last example, you take the real user manager, but a fake database service. In each test, you tell the service how it should behave, and then you check how the user manager reacts. By the way, this explains why your components should depend on protocols, not concrete implementations. There's a few types of test doubles, and they serve different purposes. You probably heard of mocks and stubs, and I will post a link with very brief explanation of these and other types. But what's important is not the name, but the general principle. You control the test doubles, and they help you make sure that the real component functions correctly. In most cases, you just trust the test doubles to behave as intended. While it is possible to test the test doubles themselves, I've never seen anyone actually do so. And that's why you better keep their logic as simple as possible. Once you've tested the business logic, you may also want to make sure your app's interface looks and works correctly. A good way to do so is by using snapshot tests. The idea is that you have reference screenshots of different UI components, individual views, their combinations, and even entire screens. Then your tests create the same components in the simulator. They take screenshots and compare them to the references. Snapshot tests are usually quick to run. At my previous company, we achieved something like 600 tests per minute, which gives you 0.1 second per test. That is quite impressive for UI testing, but of course it doesn't come close to unit tests, where it's typical to expect something like a thousandth of a second per test. The downside of snapshot tests is that they're not very quick or easy to set up. Unlike other test types I described, snapshot testing isn't available out of the box in Xcode, so you need to integrate a third-party tool. Besides, snapshot tests break quite frequently. Sometimes a switch to the next minor version of the SDK is enough to break them. And the final boss of automated testing is UI tests. Some would say this is a monster whose each side is a downside. Except one. UI tests are the closest thing we have to an actual person using your app. They don't care about your components, data types, and so on, just as the users don't care about them. UI tests check that what is shown on the screen is what's expected to be shown. And not just one screen. UI tests can easily check transitions between screens, and even entire flows in your app. Technically, nothing stops you from testing the entire app in a single UI test. But there's a good reason why you shouldn't do so. And once again, it comes down to the scope. As the scope of a test increases, it becomes more fragile. Now virtually any change in the code base can break the test. To keep a healthy balance of different kinds of tests in your project, there's a framework called the test pyramid. It's a simple concept, but it helps quite a lot. This is the test pyramid, or at least it's one of the versions you can come across. Each level in the pyramid is one kind of test. Neither the pyramid's shape nor the level's order is accidental. You've got unit tests in the base, because they provide the foundation of your code stability. Unit tests are small and sturdy. They are easy to write, easy to use, and easy to fix. But at the same time, you need a lot of them, and that is why this level of the pyramid has the biggest width. As you move upward, you've got component and integration tests. They are more fragile, but each test covers a bigger portion of your app, and that's why you need fewer of them. Then there's UI and API tests. They are grouped together because they're similar in how they test your app from the outside, without knowing what is actually happening in the code. Writing and maintaining such tests can sometimes be a pain, so it's pretty normal to implement UI and API tests after every other type. The good news is that you don't need too many of them for sufficient coverage. For example, in one of my pet projects, I have about 10 unit and integration tests for each UI test. This version of the pyramid includes manual and exploratory testing, while some other versions skip them. I chose this one because these tests are still part of your setup, even though it's no longer truly automated. You can have hundreds of tests, and even tests for tests, but then you'll still miss something, simply because you didn't expect it. For example, even with UI tests, it's hard to validate the scenario where the user minimizes and reopens the app in the middle of some operation. So in many cases, just using your phone as a regular person and trying to find something is the right thing to do. Strictly speaking, you don't need to have every level of the pyramid present in your project. As I mentioned, it's quite common to skip UI tests and check the interface manually, but you should understand the trade-offs. If you remove the bottom levels, or if you don't have sufficient coverage, then your pyramid becomes unstable. At this point, virtually anything can break your app, and while UI tests can tell you about this fact, they won't help with tracking down the reason. Choosing not to implement UI tests and not testing your app manually will have different consequences. Your app may just not work. And who would care about all your unit tests being green if the app simply doesn't do what it's supposed to? In my personal projects, when I don't have enough time to do everything perfectly, I skip UI and snapshot testing. That's because in my case, just setting up the infrastructure will probably take more time than testing the app manually, 100 times. But in projects with dozens or 100 developers, relying on manual testing will not be a good idea. Moving on to the actual tools we use for testing, let's have a look at what we get out of the box in Xcode. The main thing we use to test code in apps for iOS, macOS, and all other Apple platforms is the XCTest framework. It's not new, it's been around since the days of Objective-C. But it does the job and doesn't require a complicated setup. Importantly, XCTest is built into Xcode, and for those 10 people who use Swift on Linux, myself included, XCTest kinda works there too. XCTest is easy to set up and use for testing your business logic. The test suites just import the production components and can do all kinds of stuff with them. XCTest also comes with the tools for UI testing, although such tests are notoriously slow and fragile. How slow? Well, a single test can take 10, 30, or even 60 seconds to run. And I call them fragile because UI tests run in a separate process. They can observe the app from the outside, but they don't have access to its actual code. Basically, UI tests simulate the user interacting with your app the same way they normally would. But the tests don't use computer vision or some other fancy tech. Instead, they navigate your app using the accessibility tools. These tools were primarily designed for VoiceOver. UI tests don't interact with your production code. As a result, you don't get compile time errors when you forget to update the tests after changing some part of the UI. Your tests are likely to break in that case, but you'll have to run them to see if they pass. In many scenarios, you can speed up user interface testing by implementing snapshot checks instead of full-fledged UI tests. But XCTest doesn't provide any tools for that. If you're interested in user interface testing, I'll post a couple links in the description. And if you want a separate video on that, let me know in the comments. In this video, I outlined the key concepts of automated testing, those that are most relevant for software engineers. I emphasize this because actually testing is part of a separate domain in software development, quality assurance. While it's common for software engineers to implement some automation, there's definitely much more to it. I'm not a QA engineer, so I don't think I have enough expertise in those QA engineering things. If you're interested in quality assurance specifically, I'm sure you can find a lot of resources. But for the engineers who just happen to write tests from time to time, I saved one really exciting thing for last. Well, actually, I saved it for the next video, so it's only a teaser. This thing is a whole new testing framework called Swift Testing. It was announced at WWDC, and it's coming this fall in Xcode 16. I've had a chance to try Swift testing in beta, and even demoed it in my WWDC video. Swift testing is not something radically different, so today's video will stay relevant for a long time perhaps. But Swift testing ships a number of very nice features, and I'll be excited to have a closer look at it in one of the future videos. Subscribe to the Swiftbird so you don't miss the episode on Swift testing and many others. And hit the like button if you learned something new today. I'll see you soon. Until then, make your tests fly.